Hello everyone, this is Ramen Samanta from Coachbihar Government Engineering College. My department is Electronic and Communication Engineering. Subject code EC503 for CA1 presentation. My topic is pulse code modulation. What is pulse code modulation? Pulse code modulation is defined as the conversion of sample analog signal into digital signal, which are in the form of a series of on or off. Amplitudes represents as binary 0 and 1. Here's the pulse code modulation block diagram. At first, modulating signal MOT, then PCM pulse code modulation transmitter, then channel, then pulse code modulation receiver, then modulated signal. Then quantization. When an information signal is pulse amplitude modulated, it becomes discrete in time only. It remains analog in amplitudes since all the values within the specified range are allowed. PAM pulse amplitude modulation signal is said to be quantized when each pulse of PAM pulse amplitude modulation signal is adjusted in amplitude to coincide with the nearest level within a finite set. It is clear from the figure below quantization error noise can be reduced by increasing number of quantization level L, decreasing the interval between the level. Here's the figure. Then transmitter bandwidth in pulse code modulation. The transmission bandwidth of a pulse code modulation system is associated with a number of bits per sample. If the number of bits per sample increased, the bandwidth also increased. In order to have a good approximation, a large number of levels must be used, but that will lead to a larger bandwidth requirement. Let us consider each quantizer level is represented by n binary digit. Then the level represents by n binary digit. It given as q is equal to 2 to the power n, where q is the digital level of quantizer. Every sample is changed into n bits, thus a number of bit per sample is n. As we have already discussed, the number of sample per second is f of s, hence the number of bits per second, which is also termed as signaling rate, is given as r is equal to n f of s, where bandwidth greater than equals to 1 by 2r, as transmission bandwidth is half of the signaling rate. As we have already discussed, r is equal to n of s, therefore we can write bandwidth greater than equal to 1 by 2 n f of s, but we know f of s greater than equal to 2 f of n. Thus the bandwidth of PCM pulse code modulation system is given as bandwidth greater than equal to n f of m. Next, signal to quantization noise ratio. We can say SQNR or SN subscription QR. Signal to quantization noise ratio is widely used to quality measure in analyzing digiting scheme such as pulse code modulation. The SQNR formula is derived from the general signal to noise ratio SNR formula. You can see where P of E is the probability of receiver bit error, MP is the peak message signal level, MM is the main message signal level. Thank you.